Data flow diagrams are ways of representing the flow of data in a system. DFDs are useful in trying to see what kinds of data is required for a process, and these can also be used in determining requirements for database design. There are four main symbols in the gain and sarson sets. A rounded rectangle represents a process, which is something that is done. A DFD doesn't specify who performs a process, so that means it can be a manual or an automated one. Remember that the main point of a DFD is to show data flow, not responsibility. The next symbol is a rectangle, which is a source or a sink for information. Sources or sinks are usually external to a system. For example, in a retail setting, the system could include the registers, credit card machines, and back-end networking equipment. A source or a sink would be a customer. They're not part of the system, but they feed data into it by way of purchasing and paying for items. A source provides data to a system, such as the customer in this example, and a sink receives information, like a shareholder or a manager receiving financial reports from this system. The next symbol is an open-ended rectangle, which represents a data store. This isn't necessarily a database. A data store can be a filing cabinet or a notebook, as well as a database or a spreadsheet. Finally, the last symbol is an arrow, which represents the flow of data from one place to another. To illustrate how to draw a DFD, let's look at the class registration process. A context diagram shows the system represented by a rounded rectangle and all the associated external entities. It also shows the different types of data that flows between the system and the source or sinks. In this case, students feed data into the system, namely, they need to supply their student information such as their name, password, and student number, and the system feeds back to the student their schedule information, which may include section numbers, room numbers, instructor names, meeting days and times, and how many credits each class is worth. The system also needs data from other places. The business office supplies the system information about the student's financial obligations. If the student has any outstanding tuition or fees, the business office notifies the system, who then notifies the student. Likewise, the registrar's office lets the student know if there are issues with prerequisites or if the student already took a class and thus cannot take it again. Again, this is a high-level view of how registration works. If we were to look more closely at how this process works, we then look at diagram 0. In this diagram, the system is broken down into different processes. You'll notice that the new processes and data store in the middle of the diagram illustrate what happens when students register for classes, and that all the sources and sinks are still in place with the same data inflows and outflows. Usually when drawing a DFD, the processes are numbered in order that they typically happen. In this case, the first thing that happens when students sign up for classes is for the system to verify that the student is who they say they are. Once they have been authenticated, the student can then pick the classes they want. For this process, the system will refer to a data store that has available class information. Once that process is complete, the student's schedule is ready to go. The system first checks if there are any issues with the student's account, either because of fees or academic reasons. After that checks out, the registration process is complete, and the student is given their schedule for the next semester. Each data flow must be labeled with the type of data involved. Student info, for example, may include a student's registered name, username, password, and student number. Schedule info may be the section and course number that the student knows from looking it up in the catalog or course listings. Course info could include additional course information from the class database, such as the instructor, meeting days and times, and the number of credits for the course. The schedule then can be made up of data that is already in the system, the student's name and number, as well as the course information. If you identify all the sources of data involved with this system, then you can see exactly what kind of data you need from the different stores. You need information from the student for identification, you need course information to pull up details for those courses, and you need information from the business and registrar's offices to determine if the student is in good standing. You can also see that the data in the resulting schedule that is output to the student is limited to the data that was introduced into the system. The schedule isn't going to have anything about the student's major, overall GPA, or even when that student is due to graduate, because at no point was that data made available to the system. This kind of diagram can help identify a lot of requirements for a new system. From this, we can tell that we need some specific user inputs. We need an interface to the business and registrar's offices, and we can see what kind of data stores we will need to support the system. If you use specialized programs, such as case tools, to generate these DFDs, you can even get the basic elements needed for a database from the different data flows. A case tool can see that course info has a certain number of fields and can set up a table in a database for you, and then relate that table to others automatically without you having to worry about primary and foreign keys, setting up table relationships, or validation rules. It should be noted that there are no decisions made in a DFD. As we mentioned earlier, a DFD shows data flow, not responsibility, and not decisions. If a student has a fine, the process may stop while the student takes care of that, but this diagram does not show stopping or branching out to sub-processes because of decisions. When drawing DFDs, only focus on data flow and the processes involved. Don't worry about what-if scenarios. There are a few rules in drawing DFDs. For one, sources and sinks cannot directly access data stores, sources and sinks cannot directly access each other, and data stores cannot directly access each other. Sources, sinks, and data stores are basically just holders of data. Processes must take data from place to place. Data cannot spontaneously move from a data store to a sink. Additionally, processes must always have an input and an output. Data cannot spontaneously appear from a process, and a process can't hold data indefinitely. Otherwise, that process would be a sink. There's always at least one data flow into and one data flow out of a process. Let's look at another example. Here we'll draw a context diagram in a diagram 0 for a generic retail sales system. When drawing your context diagram, start by representing the system with a rounded rectangle. From there, think about the different outside entities that help the system work. In retail sales, customers are always external to the system. If customers pay with a debit or credit card, there's also a financial institution involved. With those in place, think about the different types of data that is required for the interactions. For the customer, the system needs purchase information, such as the items they're buying and their cash, check, or debit or credit card information. The system, once the process is complete, will give the customer a receipt for the transaction. If the customer pays with a debit or credit card, the system needs to communicate with the customer's financial institution to make sure the payment method is good. The system will pass along the customer's name and account information to the financial institution, and the financial institution will return some kind of a confirmation about the transaction. Keep in mind that, again, a DFD doesn't make decisions, so if a credit card is declined, there may be a different set of steps in place to get a new payment method from the customer. But diagramming that process isn't part of a DFD. All we need to know is what data flows between entities. When coming up with your diagram 0, it helps to lay out the different processes involved in the system. In this case, it's pretty straightforward. A customer presents the items they want to buy, they provide payment information, and they get a receipt. Remember that each of these steps should be action-oriented. There are things that happen within the system as a result of some input. Now, put yourself in this situation and think about what kind of data flows between each entity. The first data flow is already given, since that comes from the context diagram. Coming from the customer, purchase info can contain data like the items, quantities, pricing, and payment method information. Between processes 1.0 and 2.0, we can pass all the data along since we can separate what we need in process 2.0. There, we can send the customer's payment information to their financial institution and add that confirmation information along with the purchase information to the receipt information. Process 3.0 would involve printing that data and handing that receipt to the customer. If needed, you can further decompose each of the processes in a similar way we added detail to our original context diagram. This decomposition is called a level 1 diagram. If we want to expand on process 2.0, for example, we could detail a little more about how we would process cash, check, and debit or credit transactions. In this case, it's not really necessary to do so, but if there were other steps or entities involved, it might be worth showing how these worked.